All right, this lesson is on multiplying and dividing rational expressions and rational functions as well. Now, a rational function or a rational expression is a polynomial divided by another polynomial. Some examples of rational expressions would be x divided by x plus 3, x squared minus 1 over x cubed plus x minus 5, and 2 over x. These are all examples of rational expressions because they're a polynomial divided by a polynomial. Now, a rational function is basically the same thing. We just use our function notation. For instance, f of x equals x squared minus 1 over x cubed plus x minus 5. I use my function notation here, and that's called a rational function. Now, how do we find the domain of a rational function? If you recall from a previous chapter, domain is all possible values for x. Let's take a look at this rational function. F of x equals x plus 4 over x minus 6. Now I can plug in anything I want in there for x except 6, and the reason for that is because if I put 6 in for x, I would have division by 0. F of 6 is 6 plus 4 over 6 minus 6, 10 over 0, which is undefined. So what we would say is f of x is undefined for x equals 6. So what's the domain? The domain is anything except 6. I can plug in any other number I want except 6. The shortest way of writing that is this way. My domain is all x's as long as they are not 6. You could write it in interval notation, but it's a bit longer. This is the interval notation version. All numbers that are not 6. So I could go from negative infinity up to, but not including 6, union 6 to infinity. That's everything except 6, and that's our domain. Here's another example. Suppose I have the rational function x plus 3 over x squared minus 4x plus 3. Now the domain, as we've talked about, is all possible values for x. I have to see what's going to cause division by 0 here, because I have to exclude those x values. And the way I can do that with this one is I could factor the denominator. And the denominator factors to x minus 3, x minus 1. In this form, I can tell right here that if I plug in 3 for x, I'll get division by 0. And also here, if I plug in 1 for x, I get division by 0. So it's undefined for those values right there. Since it's undefined for those values, we would say that the domain is everything except, excuse me, my domain is all x's as long as x is not equal to 1 or to 3. Everything except 1 and 3 is our domain. Another example. Find the domain again. Let's say we have f of x equals 1 over x squared minus 4. If I factor the denominator, notice it's a difference of squares. We learned from the previous chapter. That factors to x plus 2, x minus 2. And I can tell now that we are undefined. Undefined, let me fix that, that's a little floppy. Undefined when x equals negative 2 from up there, and when x equals positive 2 from there. You plug those numbers in and you're going to have division by 0. So our domain for this one is all x's as long as x is not equal to plus or minus 2. You could write the 2 and the negative 2 out if you want. One more, g of x. Let's say we have x plus 3 over 5. Or actually, let me fix that. It's not the one I want. I want x squared plus 1. I want the domain. So I have to figure out, well, what x value causes division by 0? And if you look here, if I plug in x equals 1, that doesn't cause division by 0. If I plug in negative 1 in there, negative 1 squared is 1, plus 1 is 2, that doesn't cause division by 0 either. And so nothing causes division by 0 here. And so the domain for this one is all real numbers. You can plug in any x you want. Nothing causes division by 0. I don't have to worry about it for this one. So some rational functions do have a domain that is all real numbers. Okay. Next topic is simplifying a rational expression. Let's take a simple example to start here. Let's say you had 6 over 8 and you wanted to reduce that fraction. What you do, though you may not show the step, is you think of the 6 as 2 times 3. So I'm factoring 6, 2 times 3. And I'm going to factor 8 as 2 times 4. Now I have a 2 over a 2 here, which reduces to 1. Some instructors just tell you cross it out, but it really reduces to 1. And I'm left with 3/4. And so what I've done is I've reduced the fraction to 3/4. So simplifying, or some books say reduce, same thing here. Let's say I have 8k over 16. Well, that's 8 times k over 8 times 2. The 8s will reduce to 1, and I am left with k over 2, and I've simplified or I've reduced the rational expression. Next one is, where'd it go? Oh, here it is. 3y plus 9 over y squared minus 9. Now, I cannot just cross out the 9s. That would be wrong. What I have to do first is factor everything. Factor everything first. That is the key to simplifying the rational expressions correctly. So what I'm going to do is factor a 3 out of the numerator, and that leaves me with y plus 3. I'm going to factor the denominator. Notice it's a difference of squares. It's y plus 3, y minus 3. Now I can reduce common factors. In other words, that right there, y plus 3 over y plus 3 reduces to 1, just like it did here with the 8s and where it did here with the 2s. It's the same concept. And I'm left with 3 in the numerator over y minus 3 in the denominator. And I've simplified the fraction. There's my answer right there. Okay, it is wrong to do this. You cannot just cross out 9s and maybe cross out a y like that. That's a big no. Don't do that. That's completely wrong. You must factor everything first. Let's look at a couple more examples. Simplify or reduce. A squared minus A minus 6 over A squared plus 5A plus 6. As I said earlier, to reduce these things, you need to factor everything first. The numerator factors to A minus 3, A plus 2. The denominator factors to A plus 3, A plus 2. Yeah, that's right. I can now reduce common factors in the numerator and the denominator. Right there, that reduces to 1. And so I'm left with A minus 3 over A plus 3. And that is my answer. As similar as the numerator and the denominator look, A minus 3 over A plus 3 looks, well, they look practically the same. Even though the numerator and the denominator are similar, they are not identical. There's nothing I could factor out of them anymore. I cannot reduce that any further. That's my answer. Okay, let's take a look at this one. Let me move that down a bit. Y squared minus 4 over 2y plus 4. Once again, I'm going to factor everything first. We have a difference of squares in the numerator, so that's y plus 2y minus 2. In the denominator, I can factor out a 2, and that leaves me with y plus 2. Everything is factored. I can now reduce. That reduces to 1 there, and I'm left with y minus 2 over 2. And I'm done. There's my answer. Here's another common mistake. Y minus 2 over 2. Cross out the 2's. That is wrong. No, you cannot do that. And the reason is because 2 here is not a factor. It's a term. You cannot cancel terms. You can only cancel factors, things that are multiplied together. So this cannot be reduced any further. If I had something like this, now that's different. I can simplify that because I can factor 2 out of the top, then cross out the 2's, and I'd be left with y minus 1. Okay? That's okay. But this right here is not reducible any further. Next. Pick a couple out of the homework set. Y squared minus 5y minus 14 over y squared plus y minus 2. And once again, we're simplifying these expressions. So I factor everything first. The numerator factors to y minus 7, y plus 2. The denominator factors to y plus 2, y minus 1. I have a common factor here which will reduce, and I'm left with y minus 7 over y minus 1, and it's simplified. Suppose I have x minus 12 over 12 minus x. To simplify this, what I can do is factor a negative 1 out of either the numerator or the denominator. I'll factor it out of the numerator here. If you factor negative 1 out of here, that makes this x a negative x, and that makes this 12 right here a positive 12. Now, negative x plus 12 is the same as 12 minus x. So I can rewrite it this way. 12 minus x, and in the denominator I have a 12 minus x. I can reduce those, and I am left with negative 1. Left with negative 1. Another example of that. Let's say I have 5 minus x over x minus 5. To simplify, I factor a negative 1 out of the top. And all that really does is it reverses the 5 and the x. So this becomes x minus 5 over x minus 5. I can then reduce these common factors, and this is equal to negative 1, just like the previous example. 5 minus x over 5 plus x. No matter what I do, factor out a negative 1 out of the numerator or the denominator, I can't make them look identical. I can't turn them into identical factors, and so this one cannot be reduced. Cannot be reduced. And we got one more example, and it is right here. Simplify. We've got 5k minus 10 over 20 minus 10k. So I'm going to factor everything first. I'm going to factor a 5 out of the numerator. I can factor 10 out of the denominator. Leaves me 2 minus k. Now notice that this and this I can reduce if I factor a negative 1 out of the top, just like I was doing in the last problem. And so I'm going to split this up. That's 5 over 10 there. This is a negative 1 times a 2 minus k over a 2 minus k. I factored negative 1 out of the top, out of the numerator. These will reduce now, and I'm left with 5 over 10, that's the 1/2, times a negative 1. My answer is negative 1/2, and it's reduced. And that is our lesson on simplifying rational expressions. Part 2 will be on the multiplying and the dividing.